Hi class, in this video we're completing our Standard 16 study guide on coordinate geometry. First question says, which equation represents a circle centered at -3, 8 with a radius of 7? The key here is that we have to switch signs on the center, and we have to square the radius. So that's why our answer is B, because we switch signs. The -3 becomes +3. The +8 becomes -8, and squaring 7 becomes 49. In the second equation, we're looking to come up with an equation for this circle. So the center is at coordinates 3, 2, and counting the radius is 1, 2, 3, 4. So finding the equation that has center 3, 2, we have to switch signs. So that's why it would be D here with radius 4. 4 times 4 is 16. The third question, which of the following is not a perfect square? In order for it to be a perfect square, you could take the middle number, the B number, and it's half of B multiplied by itself has got to be C. So in this first problem, if I take that B value, that middle value, -2, half of -2 is -1. -1 times -1 is +1 and not 4. So that says that the answer is A, that first one is not a perfect square. Compared to the second one, where half of 8 is 4 and 4 times 4 is 16. So that works, and so forth. Next one, determine the center and radius of the given circles. Okay, so we have to switch signs. So our center is at -4 and 2, and our radius is at that square root of that value, so that's 3. For the next one, our center is at +7, and that y squared's by itself, so +7, 0, and the radius is at the square root of 64, which is 8. Next one, determining the equation of the circle, we would have x squared plus y minus 6, switching signs, is equal to that radius squared, so that's 4. The next one, switching signs, will have x plus 2 squared plus y plus 1 squared is equal to that radius squared, so 8 squared is 64. In this problem, we have to complete the square in order to find the center and radius of the circle. So if we first order the problem, we'll have x squared plus 2x. I'll leave room for a blank. And then for the y's, we'll have y squared, so plus y squared minus 6y plus room for that blank. And that's going to equal taking that -6 there and adding 6 to both sides. So when we complete the square here, half of B, half of 2 is 1, and then 1 times 1 is 1. So that number there is 1. And then we're going to add 1 to that other side. Then for the blue problem, half of -3, half of -6 is -3, and -3 times itself is 9, so a 9 goes there and there. So on this side of the equation we'll have 16. On the other side of the equation, these complete as half of B, so the red problem becomes x plus 1 squared plus y minus 3 squared, that's half of B, is 16. So the center is at, switching signs, -1, +3, and the radius is at the square root of 16, which is 4. Doing another problem, we'll first organize our problem. So x squared plus 16x plus the blank plus the y values, so y squared minus 10y plus the blank is going to equal to the constant, so add 11 on both sides. Okay, then figuring out what number goes there. Half of 16 is 8. 8 times 8 is 64, so add 64 to both sides. Then Half of negative 10 is negative 5 times itself is 25. So add 25 to both sides. On the right side of the equation, we get 100. On the left side, we'll get x plus half of b, so x plus 8 squared, plus parenthesis y minus 5 squared, that's half of b, is 100. The center is at negative 8, 5 switching signs, and the radius is at 10 square rooting. The next ones, we're determining the slope of the line, where slope is change in y over change in x. Okay, so the change in y's go from negative 3 to 5. So negative 3 to 5 increases by 8. Then the change in x's go from 4 to 7. So going from 4 to 7 increases by 3. Therefore, the slope is 8/3. In the next problem, the slope is again change in y compared with change in x. So the y goes from 4 to 4, so that's 0. The x goes from negative 2 to 5. So from negative 2 to 5 increases by 7, but 0 divided by 7 is 0, so that slope is 0. For number 8, the midpoint is the middle point, which is the average of the coordinates. So the average of the x coordinates. So the x value will be 5 plus 2 divided by 2, and averaging that out, you get 3.5. The y value will be averaging the y coordinates. So that's negative 3 plus negative 7 divided by 2, which is negative 10 divided by 2, which is negative 5. So the midpoint is at 3.5 and negative 5. So point there, 3.5 and negative 5. Doing the next one, the x values averaging out 7 and 11, the middle number, that x value middle number is 9. 9 is in the middle. For the y value, I'll calculate that out, negative 1 plus negative 4 divided by 2. That's negative 5 divided by 2, which is negative 2.5. So the midpoint is at 9 and negative 2.5. That's the middle value between these 2 points. Next ones, we're determining the distance. So distance is the Pythagorean theorem. That diagonal distance, d squared. The distance squared is the change in x squared plus the change in y squared. So figuring that out, distance squared, the change in x goes from 3 to negative 1. So that changes by 4. So whether it goes up or down, it doesn't matter for the distance. Then the change in y values go from 6 to 9, so that changes by 3. So the distance squared is 16 plus 9, which is 25. Square rooted, that distance is 5. Drawing that out on a triangle, we'd have that the change in x's is from 3 to negative 1, so that's 4. The change in y's is from 6 to 9, so that's 3. And we're finding that x distance, which is 5, because it's a 3, 4, 5 triangle. So the distance between the points is 5. Doing this problem, the distance squared is the change in x squared plus the change in y squared. So that's Pythagorean theorem. Drawing out a triangle at the same time. The change in x goes from negative 2 to negative 6. So that changes by 4. The y values go from negative 3 to 4, which is actually a change of 7. So figuring this out, we'll have distance squared is change in x squared plus change in y squared. So that'll be 16 plus 49. Which is 65. So the distance is going to equal the square root of 65, which equals a distance of 8.1. That's that diagonal distance between the points is 8.1. In the next problem, we're given the endpoints of the diameter, and we're looking for an equation of the circle. So the first thing we want to do is graph those 2 points. So graphing those points, -7, 2, and -1, 2, what I can see, first of all, is that the center of that circle, so the circle will be just a rough drawing right there. There's our circle. So the center of the circle would have to be the midpoint of A and B. That midpoint is going to be, and I could just visually draw that in there, at -4, 2. So -4, 2 is the midpoint of A and B. That's the average of those 2 points. The radius, I could just count that radius to be a radius of 3. So with that information, center -4, 2 and radius 3, my equation is going to be switching signs, x plus 4 squared plus y minus 2 squared equals 9. Next one, we're finding the missing coordinates of the shape. So the first is a square, ABCD. So I could plot those points. And in plotting them, I could see that the fourth point of the square would have to be at 0, 2. For the next problem, plotting those 3 points of the parallelogram, I can see that my fourth point, so this one has a slope right there, and since parallelograms have the same slope, here's the slope of -2, here's my fourth point. So when I connect that, I see that I have that parallelogram right there. So that fourth point is at coordinates -6 and 3. And finally, for the rectangle, I see that I have a slope here that goes up 1 and over 2. So then on the other side, I'll have to go down 1 and left 2 to that point right there in order to make the rectangle. So that has coordinates of 5 and -1. For the next problem, we're determining the most specific name for the quadrilateral with the vertices A, B, C, D. So first I will graph them. When I graph those 4 points, A, B, C, D, my gut feeling is that this is going to be our rectangle. So let's see if we could find more evidence to see if this is a rectangle or not. One way to show that this is a rectangle is to check the lengths of the diagonals. So if I look from A to C, okay, so from going from A to C, I'll draw in a right triangle right there and calculate out that length. So that right triangle right there is 1 by a length of 1, 2, 3, 4, 5, 6, 7. 1 by 7. So that diagonal length then would be 1 squared plus 7 squared, and that's going to be square rooted. So that's 1 plus 49, so square root of 50. So that diagonal length is square root of 50. Okay, finding the other diagonal length, and that's from B to D. So from B to D, that diagonal length right there, if I draw in a right triangle, that right triangle has dimensions that go by 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So finding the length of BD, it's 5 squared plus 5 squared. That's the Pythagorean theorem. So that's 25 plus 25 is 50. And what I see is both of those diagonals are the same length. Therefore, we have enough evidence that this is in fact a rectangle. So writing that up, first of all, I'll write that AC equals the square root of 50 and BD equals the square root of 50. The length from A to C is square root of 50. Length from B to D is the square root of 50. Next, I'll note that diagonals AC and BD are congruent since they are the same length. Finally, I'll note that ABCD is a rectangle since the diagonals are the same length. Last problem, we're determining the perimeter and area of this triangle. Okay, so calculating out the perimeter, I will start by putting a box around the triangle. Okay, then I will calculate those three lengths to find the perimeter. So the sides. The first triangle is 5 by 3, so calculating that out, 5 squared plus 3 squared is that first length squared. So that's 25 plus 9, which is 34. So square root of 34 is approximately 5.8. So that first distance is 5.8. Okay, next distance. The next distance I could see is 4 by 3, so that makes a 3, 4, 5 right triangle. So that second distance is a 5. And finally, I'll count my distances for my third triangle. I'll be 2 by 1, 2, 3, 4, 5, 6, 7. So calculating that out, I'll have x squared is 2 squared plus 7 squared. So that'll be 4 plus 49, which is 53. So the square root of 53 is that distance, which is approximately 7.3. So it looks like that whole perimeter is going to be 5.8 plus 5 plus 7.3, so that equals approximately 18.1 units long. Finally, we'll calculate out the area. One way to get the area of the triangle is that it's the rectangle. Take away the 3 right triangles. Okay, so the area of the rectangle is 5 by 7. So 5 times 7 is 35. And then we're going to take away the 3 rectangles, or the 3 right triangles. So the one is 5 by 3. 5 by 3, so 5 times 3 is 15. Half of that's 7.5. So we'll take away 7.5 for the first one. The second one is 4 by 3, so 4 times 3 is 12. Half of that is 6, so we'll also take away 6. The last triangle is 2 by 7, so 2 times 7 is 14. Half of that is 7, so take away 7. And calculating that out, we'll get, and in reviewing, it's this calculation right here. 35 is the rectangle, and the 3 triangles are 7.5, 6, and 7. So that equals 35 minus 20.5, which equals an area of 14.5 squares. Good luck on the quiz tomorrow.